First, there was nothing, and then there was something. 13.7 billion years ago, the Big Bang occurred, and the universe, as we know it, began to be formed. During the time of the Big Bang, the universe was relatively very small and very hot and very dense. Just a few millionths of a second after the Big Bang, the universe had started to cool and expand. This cooling caused electrons to form, and just another few millionths of a second later, neutrons and protons formed, and then combined into nuclei due to the strong nuclear force. 380,000 years after that, the electrons began orbiting around the nuclei, marking the creation of the first atoms. At the time, these atoms really only formed hydrogen and helium, which are still by far the most abundant elements in the entire universe. After those 300,000 years, it was very, very dark. This is what we refer to as the Dark Ages of the universe. During this time, it was very hard for us to know what was happening since light had not enveloped the universe yet. But after 400 million years, we can start to see what was happening. At this time, the first stars and galaxies were beginning to form due to gravity, clumping together huge clouds of gas, and the universe was finally lit up as we see it today. Fast forwarding about 9 billion years, we come closer to home. This was when the solar system began to be formed by way of the condensation theory, where a large solar nebula contracts under the force of its own gravity to start flattening into a disk and spinning. This is what led to the Sun and planets as we know them, our very own Earth being one of them. This beginning era, after its initial formation of Earth, is referred to as the Hadean Eon, in reference to the molten activity that took place during this time. During the Hadean Eon, Earth was still in the process of forming an entirely solid crust, so there was a lot more volcanic activity. Temperatures were too hot for life to have begun to exist, and tectonic movement occurred much faster. Not only was Earth beginning to form its outer layer, but the Moon was created during this time as well. The most common explanation for how the Moon came to be is that an object, roughly the size of Mars, crashed into Earth while the Earth was still in this super hot state, and the crust not entirely formed, which ejected an absurd amount of material from Earth into orbit around it. This material came together under the force of gravity to form the Moon over a couple billion years. This theory is backed up by evidence from 2011, where uranium-lead dating, a form of radiometric dating used to determine the age of geologic substances, was implemented on material from the Moon, and it came back being dated about 20 to 100 million years younger than the Earth. After the Hadean Eon came the Archean Eon. During this time, the Earth started to cool enough to form solid continents and a liquid ocean. This is when life first started to occupy Earth. The first single-celled organisms, prokaryotes, originated during this time, specifically in the form of cyanobacteria. The defining characteristic of the Archean Eon was that life first sprouted during this time, but complex life had yet to appear. This was due to the fact that the atmosphere of Earth had yet to be oxygenated. There was small trace amounts of oxygen during this time, around 1 to 2% of what we have on Earth now, not enough to support the vast amount of life we currently see. The oxygenation of the atmosphere occurred in the eon after, during the Proterozoic Eon. During this time, the atmosphere not only became oxygenated, but also formed the ozone layer that happens to protect against organisms from the harmful ultraviolet rays that our sun emits. These factors all combined to help form the first eukaryotes, relatively complex multicellular organisms. Not only were eukaryotes born out of the Proterozoic Eon, so too were animals. At the border between the Proterozoic Eon and the Phanerozoic Eon, the one we currently live in, a proliferation of life occurred where complex organisms such as trilobites first came to be. This proliferation marks the beginning of our current eon and the end of the Precambrian supereon. After this proliferation of life, our current eon, the Phanerozoic Eon, begins, and with it, the Paleozoic era. During this era, Earth was bursting out the seams with life after the enormous proliferation previously. plant life flourished, insects and bugs first came into existence. Even amphibians and reptiles originated at this time. Marine life was also extremely abundant, until the Great Dying. During this extinction event, the largest in Earth's history, 90% of marine life and 70% of terrestrial organisms became extinct. The exact cause of this event is not entirely known, but many think it was caused by one of the largest known volcanic events, the eruption of the Siberian Traps, which would have had continuous eruptions for nearly 2 million years. After the Great Dying, the Mesozoic era begins. This is where the dinosaurs come into creation. Reptiles ruled the Mesozoic era, both on land and in the sea. But there was also the beginning of other types of animals. Birds first appeared during this time, and the very first mammals as well, small and rat-like. Unfortunately, though, the dinosaurs as we think of them died off in an extinction event as well, the KT event, commonly thought to be an asteroid that landed around the Yucatan Peninsula in Mexico. After this, we finally come to the Cenozoic era, where mammals are the defining characteristic. We humans evolved during this time, just in the last few million years. But since then, we have become the apex predator of the planet, being smarter and more adaptable than anything that has come before us. With advancements in science and technology, with people like Newton developing the laws of mechanics and defining the principle of gravity, and Einstein solving the problem of the photoelectric effect and developing the ideas of quantum mechanics and general relativity as well. We learn more and more about the mysteries of our world, from astronomy to physics, to chemistry, to geology, and even biology. Everything coexists to form an enormous picture of our universe.